All right, greetings everyone. Good evening. Good afternoon, everybody, or good evening, everyone.
Good night, sir.
Good evening, sir. Good night, sir.
All right. Lovely. Right. So we are about to complete our first week in March. All right. About to complete our first week. Let's see here. Okay. All right. No updates or no announcements for you. I would have given you all that last class. Just a reminder that next week the link will be changing. I'm only giving you guys an additional week. I'm supposed to change the link next week, but I'm just giving you guys until next week, Wednesday, to get everything sorted out. All right. So not next week, but the other week is when the link is going to change. Okay. And please be reminded that the school closes on April the 30th, but I'll be teaching you for 4 additional days in May. Right, so when everybody is stuck going to classes and it's just you'll be coming to classes for 4 back-to-back days in the first week of May. Okay? Because you guys had lost out some time in Melissa. So we're trying our very best because only 1 week we're gonna have in May before the whole entire school is taken over by CXE. So just to remind you. All right, guys. So I'll try my very best to give you back that time. We had already planned to do it, and it's just that I didn't tell you. All right. But yeah, man. So I have to just to give you back at least another 6 or 7 hours additional teaching. All right, good. So where are we at now? Where are we at? Where are we at? Last week Wednesday, what did we do? Yeah, guys, go ahead. What was it? What? Where did we stop last week Wednesday?
Sir, I think it is enlargement transformation.
Okay, good, lovely. All right, so we would have completed that topic then. We would have completed that topic. So it's just some practicing that we need to do. As you would have already noticed, a few of you are coming to the Saturday classes, so you can see that we've been practicing some of those stuff. We've been seeing them. So we are going to pick up on we're going to start a new topic tonight. Okay, we're not going to go back to that. We're going to practice those in our free time. So tonight we are going to move to this topic here: functions, relations, and graphs. That's the objective for the month of March. We'll be on this topic. All right, for every Wednesday, for the rest of the month of March, we'll be on this topic: functions, relations, and graphs. New topic, guys. All right, and what is it? We're going to have a lot of algebra. So the prerequisite for this topic is algebra. Right, you need to have your algebra skills. Solving equation, rearranging equations will need to be a prerequisite skill for this topic. All right, you're going to see a lot of algebra playing a role here. All right, so what's the objective? What are the things that we're expected to complete on this topic? So number 1, we're going to be looking at what is known as direct functions, which is known as input and output. So we're going to talk about direct functions, and this direct function, we refer to it as being input / output functions. All right, so that's number 1. Once we have completed this, then we're going to look at the next objective, which is going to be dealing with undefined functions. So undefined functions. Number 3, we're going to be moving into what is known as, obviously not everything tonight, guys, not everything we're going to do tonight. But these are the topics that is expected to be covered in March. So composite functions, then we're going to move into combined functions, and then transition right into what is known as inverse functions. So this covers part 1 of functions and relations. That covers the functions and relations aspect. Now, once we have an understanding of direct functions, undefined, composite, combined, and inverse, part 2 now is where we're going to be leading into what is known as the graphical part of functions and relations. And to kickstart that part, oops. So to kickstart that part, we're going to be looking at number 6, completing the square. This is where we introduce graphing to you. Completing the square. Once you have complete the square, then we're going to transition into analysis of the quadratic function. Analysis of the quadratic function. It's a deep topic, you know. So completing the square, then we're going to do an analysis of the quadratic curve or the quadratic function. From there, we're going to move into sketching curves using tables, sketching curves, sketching/drawing curves. Of different types, temperature curve, heating curve, quadratic curves, just how to draw a curve on a graph paper. Please ensure that you have a graph paper for this class. It may not be for the next 2, but once you hear me head into the graphical part right down here, you're going to need a graph or graph papers with you to follow me precisely. And then from here now, once we get into this point right here, we're exiting the topic now. We're going to move into what is called linear programming. Going to be looking into linear programming. All right, lovely. So we have 9 subtopics to complete before we cover the topic of functions and relations. Okay, I think there's one more now we're going to be looking at. So number 10 is going to be solving we're sure I'm not going to get to it still because I might have to skip some of these topics and solving simultaneous quadratic equations. So as you can see, ladies and gentlemen, just from the mapping here, it's a lot that we must do. And I'm hoping that I can complete all of this by the first week in April. Okay. Give me a minute, guys. Just a All right, lovely. So those are the topics that we're expected to complete over the course of the next month, right? While the other days now will be covering other topics as well, such as matrices, and we're currently on trigonometry. So after trigonometry, we'll be moving to other topics as well, right? But on a Wednesday, it's a lot to complete, all right? Because this is particularly, this topic appears 2 sections on the paper. It comes at question 4, 5, or 6. So you'll find these questions at question 4, 5, or 6, not 4 and 6, So question 4, 5, or 6, one of them. And then you'll find this section down here at question 8. All right. Now the questions up here are valued maybe about 6 or 7 points. And the ones down here is worth 12 points. So functions, relations, and graph is worth approximately 20 points in the exam. So it can be 6, 7, or 8 points. Down here, we know it's going to be 12 or 15. So it depends. So together, in the whole entire exam, out of the 100 points, functions and relations is worth 20% of the exam grade. This is why the topic is so long. Okay? Now, before I actually get into the discussion of these topics, I want you to see what it looks like on the exam paper. Stop sharing my screen. Sorry, stop sharing my whiteboard, pardon me. I'm going to share my screen and I'm going to go on the website and show you where you find these things. Are you guys seeing my screen?
Yes, sir.
Okay. All right, so go ahead. I'm going to go ahead and pull up a past paper. And you're going to see where this is coming from. All right, guys. So, CSEC math past paper. Go on CSEC math tutor. All right, so you can find all the past papers. I'm going to pull up the most recent ones. May 2025, May 2024, and May 2023. I wanted to see where we find them. So when I pull up May 2025, which was last year's exam, as you're seeing on the screen here, and as I scroll through, I'm going to scroll down all the way to question 4, and I'm going to spot it. And let me show you where it is. Hold on, it's coming up. It's coming up, guys. There it is right there. 2 functions, f and g, are defined. So this is what we call functions. You can see they're asking for g of -6 and inverse function. So sometimes they send a lot. You can see them there, they're there. Hence, solve the equation f of g. You're going to see a lot of these as I'm explaining. So that there, you can see, is 2025. So that came last year for sure. Let's look at the year before that. May 2024. Let's scroll down. So you guys can see if it actually came on the exam. Scroll down. Let's scroll down. Let's see. There it is again. 2 functions, f and g, are defined as follows. F of x minus 2, g of x, all that extra stuff. So it didn't come with a lot of marks that year. It only came with what this is. 2 points, 4 points. All right. 4 points. If you scroll down all the way to question 8, you'll realize what it looks like at question 8. So there it is again. Algebra, relations, functions, and graph. There is that f of x thing again. See, it's coming up, G of 2, F inverse minus F minus 1, 3. We're going to look at how to solve those problems. All right, and do you have a graph paper, which you're going to be plotting a graph. This is called a quadratic curve. We're going to be looking at all of these as we go along. Okay, and just one more evidence now. The year before that now, 2023. I want you guys to see that this thing comes very consistently. So if you scroll down to question 4 again, you might see it. Most times it comes, sometimes it doesn't. All right, let's see if you can find it. There you see it again. Consider the following functions, blah, 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 all of that good stuff. See, it's mentioned something about undefined. I will mention in our listing a while ago, undefined function, GF a quarter, all of that, F of, we're going to look at all of those. Everything that you're seeing on the screen here, you're going to learn how to do within the course, within the month of March. All right, oops, sorry, let me go back. I didn't go to the back part of the paper. So if I scroll all the way down now, question 9 for this exam paper. Let's see if we can find any more. Algebra function, there you have it. This is what they call the tables of values. And this is where they're going to give you a graph now, and you're going to have to learn how to plot the graph and get the maximum and minimum value and all of that. So I've shown you evidence that back to back, 2023, 2024, 2025, May exams, this thing consistently comes. That means with that trend, it's very obvious that more than likely it's going to come on the exam. All right? If it don't come, then thank God. But expect it to come. Okay? All right. So now you guys see that. All right, good. So where do we start? To start off this topic, right? I'm going to cut out some of the other extra details. I'm going to get straight to the point. The first thing that you want to really get into as it relates to passing an exam, we want to look at the ways how a function is represented. So we're going to look at something known as the function notations. Function notations. So what is it that CSEC uses? Or what is it in mathematics that we use to represent a function? How do we know that the question we're about to attempt is a function, relations, and graph question? Well, we use the symbols F, open bracket X, G, open bracket X, H, open bracket X, and we can go on and on forever, right? The most commonly used letters, as you would have seen on the past papers, are F, G, and H, but it's not limited to just that alone. You may end up going on the exam and see K of X, R of X, N of X, whatever letter of X. But what this simply means is that this is a function of X. F of X, you're going to be getting an equation for it, G of X or H of X. Okay? Now, there's other ways how they can be represented as well, right? So you may end up seeing something like F with 2 dots like that and an X. You may also see G with 2 dots like that and an X. And H with a dot like that, X. Now, they all mean the same thing. It's just different representations for it. But the ones in red are the ones that we say that it's... So this one is saying F of X, a function of X. This is saying a function at X. And the last one here is just an F with a little arrow like that, X. G with an arrow like that, X. H with an arrow like that, X. This means F maps onto X. So regardless of whatever they choose to represent the function, that won't change the process of how you solve problems like these. Just know that when you see that F of X, G of X, H of X thing, you know that you're dealing with a functions and relation problem. All right, lovely. Now, the next thing that you're looking at is going to be what is a relation? All right, so this is the function representation. But what exactly is a relation? What is a relation? What is a relation? So mathematically, when we define this, we say that a relation is a set of ordered pairs. Can you write that down for me, guys? A relation is a set of ordered pairs. A relation is a set of ordered pairs A relation is a set of ordered pairs that obeys a mathematical rule. A relation is a set of ordered pairs that obeys a mathematical rule. Now, here are some examples of relation, and it's going to make sense once we start working with a few problems. So when we talk about a relation, you're talking about a pair of numbers. So basically they look like this: 2, 3, 3, 4, 4, 5, for example, 5, 6. Each of these are, when you put them together, they are together called a relation. You're following a pattern. What the pattern is, now give me a sec, let me just, all right, so this is called a relation, an example of a relation. And the pattern that it's following is that it's telling you to take 2 steps on the X to your right, 3 steps up on the Y. This is saying 3 steps on the X, 4 step on the Y. 4 step on the X, 5 step up on the Y. 5 step on the X, 6 step on the Y. It is following a pattern. So the relation is telling you where to put the point. After plotting a series of points, you're going to end up with a straight line because a function is a straight line. Well, not all functions are straight line, but the ones that we're going to be focusing on are the straight line functions. So it's going to make sense once you start working with a few problems with you. But when we talk about a relation, what we're talking about is a pair of brackets with some numbers inside them. Okay? All right. So what is this question going to look like? What are they expecting? What do you expect it to see? To start this off, if we start off with the basic, give me a sec here. Line that. Come. All right, go here. All right, good. All right, so what we need to start off with here is something known as the direct function. So we're going to start off with this topic known as the direct function. And there's 2 variations to the direct function. We have the input version of the direct function, and we have the output version of the direct function. I'm going to give you an example of each. Now, have a look. Example. F of x is equal to something simple. 3x minus 4. All right, that's the function given to you. So a function of x is equal to the equation 3x minus 4. That's what they gave you on paper. When the question is a direct function, or when we call it an input function, is when they ask you to work out something like f of 2. What they're asking you to do is to take the number that is in the bracket right here and put it right here, so, and multiply it by the 3. So whatever number is in that bracket, you're going to substitute it where the x value is and work out the problem. So what this means then is that f of 2 will work out to be 3 times 2 minus 4. 3 times 2 is 6, and it then works out that 6 minus 4 is 2. So what does this mean? What this function is saying, right, is that if you were to input 2 into the function, the output is 2 in this particular example. So you input 2, notice I took the 2 and I replace it right here. That's why it ends up right here. And then I multiply it by 3 and subtract 4, and it works out that the answer is 2. So this is what you call an input-output function. You are the one that inputted a value into the function, and based on the calculation, the function spit out or gave you an output value of 2. The relation for this would be that you input 2 and there was an output of 2. So that is your relation. That's the relation for that function. Now, not only are you going to be asked to substitute a number into the function, you may be asked to substitute something negative as well. So let us start off with example number 2 here. Let's say you end up with f of -1, something like that. Same procedure. F of -1 means that you're going to take -1. Once again, you're going to take this value right here, and you're going to put this value right here, so. That's where you're going to put it. So you're going to end up with 3 times -1 minus 4. When you work out the math, you end up with 3 times -1 is -3 minus 4. You're going to end up with an output value of -7. So what does this mean for us? It means then that you input -1 into the function given, because this is the function given. You are the one that took the -1 and put it into the function, and based on the calculation, it spit out a value of -7. So the relation for this is -1, 7. Now, example number 1, we inputted a positive number. Example number 2, you inputted a negative number. It is very likely that you may also be asked to input a fraction as well. So you may be asked to do something like same function. I'm keeping the function the same, guys. So you may be asked to input a function like, let's say you're asked to find the value of f of a half. Something like that can happen as well. F of a half. Now we're keeping the function the same. I'm not changing the function. I'm keeping this very simple function here. And so in this example, if we're asked to work out f of a half, this is going to be working out to be 3 multiplied by a half, because 3x means 3 times x. And if x is a half, then it's going to be 3 times a half minus 4. I have a little fraction to work out here. Now, 3 times 1 is 3. And 3 over 2 minus 4 over 1, and you find the LCM. That's a fraction. All right? So 3 over 2 minus 4. Now, the LCM for this, as you should know, is equal to 2. So sometimes you're going to get a fraction to work out. Normally, when you input a fraction into a function, you normally end up having to find some LCM related. So 2 into 2 goes 1 time. And 1 into 2 goes 2 times. So when you work it out, 3 times 1 is 3. And 2 times 4 is 8. So this works out nicely to be negative 5 over 2. So what does this mean? This simply means that you inputted a half into the function, and by doing the calculation, the function gave you an output of negative 5 over 2. So the relation for that particular function is a half comma negative 5 over 2. All right? Any questions thus far?
Why didn't you add the 2 and the 3, sir?
Add the 2 and the 3.
Sorry, the 2 and the 1. To get the LCM.
Why did I not add them?
Mm-hmm.
But that's not how we find LCM. If I gave you a half plus a third, what's the LCM?
It would be 6, sir.
So how do we normally find LCM? We don't normally add these at the bottom. Fraction days from September of last year. When you're finding LCM, we've never added the numbers at the bottom. We've always multiplied them. Because if you add 2 and 3 and you say the LCM is 5, but 2 cannot go into 5. 2 cannot go into 5 and 3 cannot go into 5. So we find the LCM, which is multiplying these two to get the LCM. All right. Now, does it get more challenging than this? Well, the challenge will only appear depending on the complexity of this function right here. So depending on how complicated they give you this function, then the more working out is going to be required. So let me just jump to a slightly more challenging example. All right, so let's say that I give you a function, say g. G of x is equal to something like, I don't know, let's do something like 2x minus 1 over x plus 4, something like that. Yeah, nothing too crazy. And you're then asked to work out the following. Say something like g of minus 1. Keep it like that, g of minus 1. G of minus 1 simply means that you're going to take minus 1 and replace it with any x that is in the function. So g of minus 1 will then equal to 2 times minus 1 all over minus 1 plus 4. So as you can see there, all I've done is I've replaced minus 1 with this x right here. So this x here was replaced by minus 1 right here. And this x right here was replaced by minus 1 right here. We're going to just work this out nicely. So this works out nicely to be 2 times minus 1 is negative 2. 2 multiplied by minus 1 is negative 2. Negative 2 minus 1 is minus 3. Or you can just use a calculator and don't stress yourself too much. And at the bottom, minus 1 plus 4 is going to give us 3. And it's very obvious that 3 over 3 is equal to 1, so the answer is minus 1. So once again, it is proving that you put minus 1 in the function, and the function gave you an output value of minus 1. So the relation of that function, given that value, is minus 1, minus 1. Now, the more challenging, the hardest I think it will get, and I doubt it, is probably giving you a function like that and then asking you to work out something like g of a half, something like that. I like using a half because that's the number they normally use. So g of a half. All right, and it's not challenging, it's just arithmetic. So if your arithmetic from September, October that we were working PEMDAS and all of that extra stuff is lacking, then you might lack here so as well. So your whole fraction principle will be needed. So g of a half, let's work that out. This is going to be 2 multiplied by a half minus 1. In fact, let me just change this from minus 1. You know what? Yeah, make it stay. So 2 times a half minus 1. Notice that this half right here is because of the x that is up here, divided by a half plus 4. Now, working this out, here's a perfect example where you're allowed to cancel these 2 2's right here. Because a half of 2 is 1. So you can just cancel out those 2 2's. That's the only way you can do that. Cancel out those 2 2's because you are multiplying right here. So this works out to be 1 minus 1 over, well, a half plus 4 is basically 4.5. So a half plus 4 is basically 4.5. So you can just write 4.5 here. But 1 minus 1 is 0. And we know that when you divide anything by 0, it doesn't matter what it is, the answer is going to be 0. So in this case, even if we get the bottom piece wrong, I will get the whole question wrong. So a half plus 4 is 4.5. 1 minus 1 is 0, divided by 4.5. We know that when you divide anything by 0, or 0 divided by any number, is going to be 0. So in this case, then the answer is quite straightforward. You input a half, and the output came out to be 0. And that's the basic idea behind direct function. So again, there's many types of functions you're going to encounter. You're going to encounter square root function, cube root function, square function. It's going to depend, but the point still remains. It doesn't matter what type of function they give you. When I give you a direct function, especially one that gave you the input, all you're doing, ladies and gentlemen, is that you're replacing the x. You're replacing the x that is in the function given to you by the examiner, and you're going to therefore work it out to get an output value. All right? Any questions thus far? All right, let me see if you can try. So do this one,
please.
You can always download the export the file. If you look at the top, if you look at your top right screen, look up here. I think if you look at your screen, ladies and gentlemen, let me show you. If you look right up here, so you should see 3 lines looking like that. When the class is done, you can click that link and export the file. You can export the screen, and it comes straight to your phone. So I don't know if you guys know that. But all right, if you want to take a screenshot, it's up to you. So I'm going to have you try one. I'm going to give you a function or 2 functions. I'm going to have you try it and let me know. All right, I'm going to give you 2 different functions that I didn't give you earlier to see if you can manipulate this. Okay, so here's an example. So here's an example. H of x is equal to the square root of x plus 4, and g of x equals x squared minus 1. Work out the following for me. H of 5, and I want you to also work out g of -2. I'm giving you 3 minutes to work it out and tell me what your answer is. All right, your 3 minutes is up. Did you all get 3 for your first answer?
Yes, sir.
You got 3?
Yes, sir.
Yes,
Lovely.
sir.
Yeah, man.
Yes.
Perfect. Right, I don't know why the square root moved from here, so it should have been right here. But I'm glad you guys figured it out. All right, so to work out this then, all we were asking to do is to just see the square root of 5 plus 4. That works out to be the square root of 9, which works out nicely to be 3. All right, lovely. And did you all get 3 for your answer over here again?
No, sir. I got -5.
Me know see
Yes.
you get that one. Me know you get that. I know that would happen to you because what happens now, Antonella? By the way, I heard somebody said yes, they got it. If you got 3, you're correct. If you get anything else, you're incorrect. Abigail got 3. Now, Beth, be careful of this question here. All right, this question is a setup. Very, very common 6 to do this to students. You got 3, Tajana. All right, good. So what was it that I had here? 3 of what? G of what? -2? Yeah.
Yes, sir.
All right, so look at this now. Some of you guys, what you do is you do -2 squared, like what Antonella did. So you have -2 squared -1 as opposed to -2 all squared -1. Antonella, this is what you did.
Okay.
So remember that when you plug in, when you're putting a negative number into a function, but it has a power, you have to put a bracket around it. Because when you type this on your calculator, ladies and gentlemen, When you type minus 2 squared on the calculator, it's going to tell you minus 4.
Yeah, true.
When you type minus 2 in bracket and then square it, it's going to tell you positive 4. So it's a simple question, but many students get it incorrectly. All right, so let me explain to you what this means, guys. Minus 2 squared, what this means is that it means negative 2 times 2. That's what it means, you know. It's negative 2 times 2. Negative 2 all squared means negative 2 multiplied by negative 2. So what you write down on paper will be significant to the end result that you get. Okay? So that's why Antonella, here, so you would have gotten, the calculator would have told you minus 4, minus 1, and you would have gotten minus 5, as opposed to saying minus 2 all squared is going to be 3, take away 1. Sorry, where did I get 3 from? I'm thinking about the answer. 4, take away 1, which is equal to 3. So many students will go into the exam and they will convince themselves, yes, we get it right, because the answer comes out so sweet, not knowing that this is the mistake that you've made when you left off the bracket. All right? So please be very mindful of that. Okay, lovely. All right, let me see if I can do this thing that I see my teacher do. Teacher's a lazy teacher, you know? So him don't like to rewrite stuff. All right, good. So just move it up there. So that answer g of minus 2 is equal to minus 2 all squared minus 1, which is 4 minus 1, which is equal to 3. All right, so it's just a little, not giving you anything too complicated at the moment. All right, lovely. Any questions? Okay.
Sir, I joined late. What kind of maths are these?
This is functions and relations.
Okay.
Yeah. All right, so let's go here. I'll solve this. Lovely. Good. Let's zoom up. All right, gotcha. Over here. All right, lovely. So now we're going to look at the output version of this now. So the output version. This is the reverse of what we did earlier. So this is the output version. So the output version.
Excuse me, sir.
Go ahead.
Does it mean you're going back to geometry next time or what?
Wait.
Are we finished?
Oh no, man. Geometry was. Wait. Hold on. We were supposed to start geometry tonight?
Yeah, we were supposed to continue enlargement.
Okay. So what had happened is that I guess you weren't here to remind me, because I think that's what I told you last week, right? We started a different topic instead. It's fine. I'll pick up on geometry after trig. It's okay.
Okay.
Yeah. I guess you weren't here. Somebody should have reminded me that I had instructed you last week that this week we're gonna start geometry, but it's fine. I can do geometry after. All right, so the output version of this then. Now be very careful. Watch this now, guys. F of 3 is not the same thing as saying f of x equals 3. Please pay attention to those two things. They're not the same thing. They almost look the same, but they're not. Now, f of 3, what this means is that this number right here is your input value. You are the one that will take that number and put it into the function. Over here, this is called your output value because it's outside of the bracket. So we call it the output value. In other words, then, the examples we were doing before was that we put something in and we wanted to find out, we wanted to find the value of what came out. in this version, they're telling us what came out, and we have to calculate what went in, if that makes sense to you. The examples we did before, I'm just repeating, the examples we did before was where we put something into the function, and then our calculation will produce an output, an external value. Now, the one over here is where they gave us the result of the function, and they're then asking us what was the value that was put in the function to produce the value that is right here. In other words, then, I know the answer is going to be 3, but what was the number that was placed in the function that got 3 as my answer? So it's a reverse version. That's why we call it output input. So the examples you did before was input to get output. Now this is output calculating the input. Let's give you an example. We're gonna keep everything simple. So when we get more complex, so it's the same procedure. Now let's say that I have f of x here is equal to 7x minus 1. We're keeping everything simple, right? Just so you understand what is being done. And the question that came after that says f open bracket, it says that, just write it in words, it says that write down the value of x for which f of x equals 10. That's what the question is going to look like. So they're going to give you a function, whether it be a simple one like this one or something complicated, it doesn't matter. The process is going to be the same. So I give you this function that I've placed in a red box, and the question that follows says, write down the value of x. Now we're looking for the value of x. Earlier, we were told what x is. So we're looking for the value of x for which this function is equal to 10. Now, grabbing a different color ink here, pay attention to this, guys. What this means, ladies and gentlemen, is that I am going to look at the function. Watch what going on now. So what is going to happen here is that I am going to simply replace this function right here with 10. In other words, you see this symbol right here? So let me just color it. This symbol right here. That symbol, I'm going to replace that symbol with the number 10. Because what this is saying is that this is saying the symbol f open bracket x is 10. That's what it's saying. So if I see this symbol anywhere, I'm going to put 10. If you notice, I see the symbol right here. So all I'm going to do then is put 10 right here. So I'm going to put 10 equals 7x minus 1. Because remember, it says what? F of x equals 7x minus 1. But we know that f of x is 10. We know so this symbol right here, so that symbol right there is 10. So we're basically replacing that symbol there with 10. So all I've done, guys, all I have done is that I've simply I've simply replaced this entire symbol right here with the number 10 right here. That's why I have this down here. So now this works out nicely now that I'm going to bring this over here. So 10 plus 1 is equal to 7x. So this is where the equation now, from algebra class, the equation now is coming into play. So bring over the negative 1, we get plus 1. 10 plus 1 is 11. That's equal to 7x. Therefore, if I divide both sides by 7, what this is telling me is that the value that was placed in the function was 11 over 7. So what basically this is saying is that x was 11 over 7. That means this is what I placed in the function right here. So when I worked it out, I end up getting 10 as my final answer. That's what it's basically saying. So what would be the relation for this then? Remember, the relation is input, output, you know. So basically now, we are the one that calculated the input. So basically the input then is going to be 11 over 7 and the output is going to be 10. Because they gave us the output, so they gave us the end number, and we are the one that calculated the beginning number, the number at the start, 11 over 7. So the output is 10. They gave us this output value. And we did some mathematics to get the input value right here. And that's basically how you work it out.
Sir, question.
Sure.
In the exam, if we don't write the bracket with the input output, would we lose points for that?
No, you're not required to write it. This is just because I'm teaching you functions and relations simultaneously. Unless they ask you for it.
Okay, sir.
So this is not a requirement. Unless you're requested to write it down. Noted?
Yes, sir.
All right, Antonina, good to go?
Yes, sir.
I don't know, guys. I got kicked out of the class a while ago. Antonina, you got some clarity on your question?
It's not Antonella, sir. It's Samantha.
Oh, sorry, Samantha. You got some clarity on your question?
Yes, sir.
Okay. So this voice, I always think it's Antonina. Oh, Lord. It's my whiteboard. Sorry, guys. I'm looking for my original whiteboard. Okay, lovely. All right. Let's do a couple more examples so you catch the hang of this thing. G of x is equal to the square root of 5x minus 1. What is the value of x for which let me get f from, for which g of x is equal to 25. No, let's not do 25. Let's do 5. Yes, 25. 5 is fine. For which, right. So what you're saying is that I gave you a function g of x, and the function is equal to the square root of 5x minus 1. What they're saying, let me just interpret this in layman's language. What they're saying is that they want to know what value would I need to put right there that I pointed the arrow in green. What value would have to go there so that when I put the value in here, the result that comes out is 5. That's basically what they're trying to say. So to do that, as I showed you earlier, we're simply going to replace this symbol right here with 5. This symbol right here, that G open bracket X. Don't put the 5 where the X is, you know. You're going to replace the entire symbol with 5. So if you look carefully up here, all of this symbol will be replaced with the number 5. All of that. So we're going to have 5 is equal to the square root of 5x minus 1. Now, how do we solve this? Because we are trying to find x, but x is under the root symbol. So how do we find something that is covered by a root? What do we need to do?
Remove the root.
Very good. Excellent. We're going to remove the root. Now, if this is a square root symbol, what removes a square root?
A bracket and a square.
Very good. So we're going to have 5 squared, and that's going to be equal to the square root of 5x minus 1 all squared. So the square removes the square root. Pay attention. This cancels that. So what do we have left now? We have a nice little problem here that we end up with. 5 squared is 25. And that's equal to, since the square root and the square gone, we're only left with 5x minus 1. So how we solve this now? Bring this over here. We're going to end up with 25 take away 1 equals 5x.
No, sir, plus 1.
Oh, thank you very much. Appreciate you. Plus 1, because we bring the minus 1 over. We're going to get plus 1. So this is going to be 26 is equal to 5x. And to get x, we simply divide by 5. Works out nice that x is equal to 26 over 5. 26 over 5. That's it. So depending on the type of function, which is why, as I said, the prerequisite for this particular topic is algebra, and you must be relatively okay with solving an equation. All types of equation. Equation with square, equation with 2 variables, no simultaneous though, just equations with 1 and 2 variables, different types. So your algebra in terms of solving equations is a prerequisite for, managing questions like these. Let me do another example. Now, let's say that you're given a function h of x is equal to 7x is equal to 7x minus 2 over 4. And then they say that you should find the value of x for which h of x is equal to, let me see here. So for which h of x is equal to 3. All right, now be careful, guys. There's a difference between me asking you to find out what is h of 3. God, I'm telling you, it's tricky now, Now you see me doing it now, It's not, no, it's not tricky. It's not noise. When you rest this topic for a little while, like 1 week or 2 weeks, and then when you come back and you see h of 3, and you see h of x equals 3, it will be confusing a little bit for some people. So bear in mind, guys, how do we know the difference between input and output? The input basically has the number in the bracket. The output has the number outside of the bracket. So when it's an input, you are the one that's going to put it in the function. So you're the one that's going to put the 3 right here and work it out. But when it's an output function, you're going to put the number right here instead. So be careful. So here we're looking at what is the value of x when h of x is equal to 3. So where that green arrow is on my screen, I'm going to replace that entire symbol with 3. So I'm going to end up with 3 equals 7x minus 2 over 4. Now in our Saturday classes, right, and even in this class we did it. I'm just emphasizing, I think one particular Saturday when we came, I think I came with a bunch of equation questions. Remember, Miss Gentles? And we drilled how to get rid of that number at the bottom. Can you confirm?
Yes, sir.
Yeah, man. One Saturday we come and we had an algebra sheet and we worked questions and we practiced them how to get rid of the number at the bottom. But I did it in this class. I just didn't emphasize on it much. So if you can recall here that in order for us to solve this equation, we have to get rid of that 4. To get rid of that 4, we simply have to multiply this by 4 and multiply over here also by 4 again. Some of you guys are familiar with what is called cross multiplication. That can work as well. Now, when I multiply the left and the right by 4, what happens now is that 4 times 3 is 12. And then this 4 cancels this 4, so you end up with 7x minus 2. Now, by bringing this 2 over here, we end up with 12 plus 2 equals 7x. So 14 works out to be equal to 7x. And if I divide both sides by 7, it worked out nicely that x is equal to 2. 14 divided by 7 is 2. So basically what we're saying is that the output value was 3. So here you have to jump out of the class and jump back in. Because
Okay,
on my side it's saying that it's sharing, so it must be on your end. So so what this is saying is then that you would have had to input 2 right here, so you'd have had to input 2 right there. So if you put 2 in here and work it out, you will end up with a result of 3. That's what it's saying. Okay? Now it's not going to really get any harder than that, right? It's just depending on what type of function this is up here. So it depends on how difficult they've made the function, then we'll see. I'm going to give you 1 or 2 to try. All right? Let me see how you handle it. I'm going to give you 5 minutes to do these ones though. Now, let's say that you're given a function g. So g of x is equal to three x over 4 minus 1. And I gave you h of x is equal to x over x plus 7. Something like that. Now, what is the value of x? The instruction is the same for both of them. Find the value of x. Find the value of x for which g of x, that's 1, for which g of x is equal to -4. And for part 2, find the value of x for which h of x is equal to, let me see, 19. Yeah, let's try that one. 19? No, sir. No one tried it. Hold on. 19 too big. For which h of x is equal to 5. 5. Yeah, 5. Yeah. Let's try that. Yeah. All right, go ahead. I'll give you 5 minutes. So at 8:26, we'll stop and run through those. So go ahead, guys, and make an attempt. Let's see how far you get to. I can make it available for next week. Sorry, for tomorrow night at 7. That response was for you, Stacey. All right, guys. So it is now 8:26. Let us see what you guys would have gotten for your answer. All right. Oh, Stacey, did you get my response a while ago? Stacey?
Sir, I'm in a meeting at this time, so
She text me. She asked me a while ago. Say if I can make it available for 7 o'clock tomorrow evening. All right, guys. So g of x is equal to -4. All right. So what we're gonna do is replace this. Whoops. Okay. All right, Stacey. All right. So we're gonna take this -4 and replace this symbol with -4. So I'm gonna end up with -4 is equal to 3x over 4 minus 1. All right, now as we said earlier, there's a number at the bottom, so we need to multiply by that number. We're going to multiply everything by this number here. So we're going to multiply the left by 4, multiply this also by 4, and multiply also this by 4. Once you have a number at the bottom, you have to multiply everything by the number. Let's cancel out now. 4 multiplied by -4 is -16. So remember, 4 multiplied by -4 is -16. This 4 cancel out this 4. So we end up with 3x. And -1 times 4 is -4. Now if we work this out nicely, bring over that, we're going to end up with -16 plus 4 is equal to 3x. So -12 works out nicely to be 3x. So if you divide both sides by 3, you get a nice result of x being equal to -4. All right, let me know in the comments or in the chat if you got it right or got close or we made a mistake. Or you can just speak through your microphone, whichever one is fine. So that's how you get the answer for this. So the value of x here is 4.
So I got the answer, but I did it the longer way.
That's fine. That is fine. That is fine. As long as you get the answer, that means you're mathematically correct. All right, and the last one before we get out of here, it's been a long night and a long week. So h of x is equal to 5. Let's zoom out here. So now all we're going to do, ladies and gentlefolks, is replace this symbol with 5. So we're going to end up with 5 being equal to x over x plus 7. All right, with this example now, you're going to just put this over 1 and cross multiply. Any side first, it doesn't matter. So I'm going to go 1 times x first. So 1 times x is x. I'm going to use this 5 to multiply these two terms right here. So 5 times x is 5x, and 5 times 7 is 35. All right, so therefore then, we're going to bring this over here. We're going to end up with x minus 5x equals to positive 35. Negative 4x is equal to 35. And if we work out this nicely and divide by -4, you're going to end up nicely with x being equal to -35 over 4. All right. So that is it. All right. If you feel the need, go ahead and watch the recording at 7 o'clock tomorrow. All right. Or watch it at a time convenient to you to catch back what you may have misunderstood. All right. But that is the end of tonight's session. You all have a fantastic, safe, and productive weekend. And we will connect or reconnect next week. Be safe. Have a good night, everyone.
Thank you, and same to you, sir.
Good
Good night,
night.
sir.
Good night, sir.
Good night, sir.
Good night, everyone. And remember, you can always export the PDF or export the whiteboard by clicking the 3 arrows, not arrows, 3 lines to your top left of your screen, and it comes directly to your phone.